Consider the next example. Solve dou square u by dou x square plus u is equal to 0, where u satisfies the conditions u of 0 comma y is equal to e power half and dou u by dou x of 0 comma y is equal to 1. So now you have solved, for example, solution of PDE of this type. Now what is this initial condition is about? What is u of 0 comma y is equal to e power half? It means that x is 0. When x is 0, u is e to the power half. When x is 0, this is of the form x comma y, right? So when x is 0, u is e power half, and here when x is 0, dou u by dou x is 1. Okay, remember this. When x is 0, u is e power half. When x is 0, dou u by dou x is 1. Now, to solve this partial differential equation, as I have done earlier, let us suppose that u is a function of x only. So this should be u. So write down it as u. Let us suppose that u is a function of x only. The given PDE assumes the form of ODE. This PDE assumes the form of an ODE. When you treat u as a function of x only, it becomes d square u by dx square plus u is equal to 0. d square u by dx square plus u is equal to 0. Or symbolically you can write it as d square plus 1 of u is equal to 0, where d is d by dx. Now this is an ordinary differential equation. You know how to solve this. You write down the auxiliary equation. M square plus 1 is equal to 0, or m square is minus 1. So what are the roots? M square plus 1 equal to 0, or m square is minus 1. So the roots are plus or minus I. Square root of minus 1. So it is plus or minus I. So it's of the form a plus or minus ib. So what is the solution of the ODE? U is equal to c1 cos x plus c2 sin x. The solution of the ODE is c1 cos x plus c2 sin x. So recall, when the root is of the form m is equal to a plus or minus ib, what is the solution of the ODE? It becomes y is equal to e power ax into c1 cos bx plus c2 sin bx. Here a is 0, so e power 0x becomes 1. B is 1, so bx will be x only. Here also bx will be x itself. So now the solution of PDE is got by replacing c1 and c2 by functions of y. You have the solution of ODE. From that you find the solution of PDE by replacing the constant c1 and c2 by f of y and g of y. So u is equal to f of y cos x plus g of y sin x. So what is given now? Given data is u of 0 comma y is equal to half, and dou u by dou x at 0 comma y is 1. So use it here. Given is u of 0 comma y is e to the power half. So put x equal to 0, u of 0 comma y, that is root e, is equal to, when x is 0, f of y cos 0 plus g of y sin 0. g of y sin 0. Sin 0 is 0. So this entire term becomes 0. You are left with only f of y. So f of y is equal to root e. Okay. Consider the next condition. Also given by the data, dou u by dou x is equal of 0 comma y is equal to 1. So you have u here from equation 1. So in order to get dou u by dou x, differentiate this partially with respect to x. So dou u by dou x is equal to f of y is constant. f of y into differentiation of cos x is minus sin x plus g of y into differentiation of sin x, that is cos x. So g of y cos x. Okay, so dou u by dou x is minus f of y sin x plus g of y cos x. Now use the condition when x is 0, dou u by dou x is 1. So put x equal to 0 here. What is dou u by dou x? 1. This term will be 0, sin 0, 0. This term will be g of y into cos 0, that is g of y. So g of y is equal to 1. So f of y is root e, g of y is equal to 1. Substitute here. So u is equal to root e cos x plus sin x. F of y is root e, g of y is 1. So u will be root e cos x plus 1 into sin x, that is sin x itself. I have written here, you can see g of y is equal to 1. So substitute both the values of f of y and g of y. You have u is equal to f of y cos x plus g of y sin x. So f of y is root e. So u becomes root e cos x plus sin x. So this is your required solution. We consider one more problem of similar type. This is also very simple. Solve dou square z by dou y square is equal to z, given that z equal to 0 and dou z by dou y is equal to sin x when y equal to 0. It's a simple problem. It is dou square z by dou y square is equal to z. So first step I have not written here, so you need to write by yourself. What is the first step? Just recall. You consider z as a function of y alone. Let us suppose that z is a function of y only. Then the given PDE assumes the form of an ODE. D square z by dy square is equal to z. D square z by dy square is equal to z. So what do you get? D square minus 1 equal to 0. Your auxiliary equation is m square minus 1 equal to 0, or m square is equal to 1. So what is m? Plus or minus 1. M is plus or minus 1. When m is plus or minus 1, you have z is equal to c1 e power y plus c2 e power minus y. Don't consider x, we have considered z as a function of y alone. So you are writing z in terms of y now. Okay. So let me repeat the first step here. Let us suppose that z is a function of y alone. So the given PDE assumes the form of an ODE. D square z by dy square is equal to z. Or you can write it as d square minus 1 of z is equal to 0. Auxiliary equation is m square minus 1 equal to 0. Roots are m is equal to plus or minus 1. So what is the solution of the ODE? Z is equal to c1 e power y plus c2 e power minus y. Z is equal to c1 e power y plus c2 e power minus y. Now you get the solution of PDE from the solution of ODE by replacing c1 and c2 as functions of x. So z is equal to f of x e power y plus g of x e power minus y. You have two conditions. When y is 0, z equal to 0 and dou z by dou y is equal to sin x. So you need to find dou z by dou y. What is dou z by dou y? From this f of x into differentiation of e power y, that is e power y itself, plus g of x into differentiation of e power minus y is minus e power minus y. So by the data, use the data. when y is 0, what do you get? Z is 0. So 0 is equal to f of x plus g of x. Y is 0. So e power 0, e power minus 0 all become 1. So 0 equal to f of x plus g of x. Here dou z by dou y is sin x. So sin x is equal to f of x minus g of x. So two equation, one is f of x plus g of x is equal to 0. One more is f of x minus g of x is equal to sin x. Right, I have written here, you can see f of x plus g of x equal to 0. F of x minus g of x is sin x. So if you add both, what do you get? When you add both, 2 f of x is equal to sin x, or f of x is sin x by 2. So what is g of x? Minus f of x, that is minus of sin x by 2. So substitute this in equation 1. What is your equation 1? Z is equal to f of x e power y plus g of x e power minus y. So substitute, what is z? F of x sin x by 2 e power y plus g of x, that is minus sin x by 2 e power minus y, which is equal to sin x into half into e power y minus e power minus y. So this half into e power y minus e power minus y is sin hy. So your required solution is z is equal to sin x into sin hy.